5, 9 actually is not anything new. We're just going to look at things maybe from a different lens, a different view. So if you are given the graph of f prime of x, so pay attention to what you have. If you're given the graph of f prime of x, it is important to remember that the y value on the graph gives the slope of the original f of x function. So do you see how this is reversed from yesterday? If f prime of x is greater than 0, what did we know about f of x? It's increasing. And if f prime of x is negative, what do we know about f of x? It's decreasing. All right, so in example 1, again, pay attention to which graph you're given. Is it f? Is it f prime or f double prime? So this is f prime of x. Okay, this is the graph of f prime of x. Determine when f of x is increasing and decreasing. Let me give you a quick head start. And then underneath the graph, it says, does f of x have a relative minimum, maximum, or neither at x is 2? So answer all parts. Okay, discuss at your table. Have somebody say where it's increasing, somebody where it's decreasing, and somebody else if it has a relative min, max, or neither. All right, Stephen, where is f of x increasing? Good job. From 2 to infinity, because max and y. Why is it increasing there? Good job. Yeah, we would say f prime of x is greater than or equal to 0. Okay, Peter, where is f of x decreasing? Not -1 to 2. Julia, where do you think it's decreasing? Yeah, because, Kai, why is it decreasing there? Yep, less than or equal to 0. All right, so then, Carter, do we have a relative min, max, or neither? Because f prime of x changes signs from negative to positive. And isn't that interesting, all that we got from the graph of f prime? Okay, so what we've done previously is we have looked at equations and we found first derivatives and did all this and used that first derivative test. Now we can actually use a graph to get the information. All right, example 2, a graph of g prime of x is below. So very, very similar. Determine the intervals where g of x is increasing or decreasing, and determine if g of x has any relative extrema. And all you can find are the x coordinates because we don't have an equation or a graph of g of x. So go ahead and try example 2. make sure you're finding the intervals where G is increasing, decreasing, and the relative extrema. All right, discuss at your tables. Have somebody share increasing, decreasing, and relative extreme. All right, Jack B, where is G increasing? Yep, because G prime of X is greater than or equal to 0. All right, Logan, where is G of X decreasing? Good job. Because G prime of X less than or equal to 0. All right, Jack T, are there any extrema? Can you give me one of them? Yep, okay. At X equals 0, there's a relative minimum because F prime, or sorry, this is G, sorry. G prime of X changes signs from negative to positive. All right, and Ryan B, is there a relative maximum? Yep, because G prime changes signs from positive to negative. Okay? All right, not bad, not bad. So let's take it up a level. And for example 3, it says a graph of f prime of x is above. Discuss concavity of f of x and determine if f of x has any points of inflection. All right, so stop and think here a little bit. This is f prime. Think about what you need to know for concavity. All right, if you haven't already, discuss at your table. Where is it concave up, concave down, and any points of inflection? All right, so if somebody needed help with this one, what could be some advice? How would we maybe help somebody out? Yeah, Logan?
Look at the slope of f prime of x.
Okay, the slope of f prime of x is the second derivative, correct? So if I start looking on the left side, what are the signs of these slopes? They're all negative. So what I now know is f of x is concave down from negative infinity to 1/2. And I need to double check. I was watching one of those Monday night videos, and I didn't watch the actual one, but I did a recording, and they emphasized again, increasing, decreasing includes the endpoints. But I need to dig a little further to make sure with the concavity, I still see parentheses, and I know, like, for me, and I know as students that bugs us, why is that different? So I'm going to dig a little further, but for now, and they also said on increasing, decreasing, if you did parentheses, they will not mark it wrong. Okay, they will not mark it wrong. But I would feel a little better. I do need to dig a little further, but at least for now, we're going to do the parentheses because f double prime of x is negative on that interval. Then f of x is concave up from 1/2 to infinity because those slopes are positive on that side. Then there are two criteria to be met to have a point of inflection. What are the two criteria? Bailey? Yes, that's the first one. And then what's the other piece, Eric? Good job. The second derivative has to also change signs there. So, f of x has a point of inflection at x equals 1/2 because f double prime of x equals 0 and f double prime of x changes signs at x equals 1/2. Or changes concavity, you could say. All right, so let's go old school. In example 4, what if I have a function equation? So if I'm given f of x equals 2x cubed plus 4x squared plus 2x, when is f both concave up and decreasing? So on this one, I'm going to go ahead and guide you through it. I'm going to use the first derivative. That's 6x squared plus 8x plus 2. I'm going to set it equal to 0 and find the critical points and help me find a number line for increasing and decreasing. You do know if I set it equal to 0 and that's an equation, I can divide out a common GCF. So I'm going to divide by the 2 at the same time. And this is going to factor beautifully. So I'm getting critical points at x is negative 1/3 or x is negative 1. So then if we plug in testing left, middle, and right, let's do a sine chart for f prime of x, and that's going to tell me where f is increasing and decreasing. All right, so I did that already, and I got plus on the left, negative in the middle, plus on the right. Now I'm going to jump to the second derivative. So that's 12x plus 8. If I set that equal to 0, I could divide by 4. And x is negative 2/3. So let's do a sign chart here. If I put in 0, that's positive. If I put in -1, that's negative. So if I use a highlighter, here's decreasing and concave up. So where do they overlap? Like where would you see both? Yeah, Maxon? Good job. Okay. So we're going to say f of x is both concave up and decreasing on the interval -2/3 to -1/3 because f prime of x is negative there and f double prime of x is positive there. On that interval. Now, I do want to mention a sign chart is never acceptable as evidence, okay? What is okay is where I'm writing f prime of x. This is what they want to look at, that you are saying the first derivative is negative there, the second derivative is positive there. That's the correct evidence. Now, it does help us to use a sign chart, but the graders have indicated on the AP exam a sign chart itself is not evidence. You have to then be real clear. All right, example 5. For the given function f of x, f prime of x and f double prime of x do not change signs. So I want to make sure you're reading that correctly. For the given function f of x, pause, f prime of x and f double prime of x do not change signs. So that means they're either always positive or always negative, okay? A table of values for f of x is given in the table below. So I want to pause a moment and give you a little time to think about this. In part A, is f of x increasing or decreasing? I think that's Captain Obvious from the table, right? And then B, is f of x concave up or concave down? You have to do a little further thinking. So try those. All right, discuss at your tables. Tell your answers for A and B. All right, I think A is pretty obvious. It's increasing, right? The values are going up. And how about B? Is it concave up or concave down? And how do you know? Daly, what do you think? Awesome. You are absolutely correct. All right, let's look at our last example. Oh no, it's not our last, sorry. I put example 5 twice. I can count. All right, so sorry about that. I think I inserted an extra one and then forgot to renumber them. All right, I really do know how to count. An object is speeding up if velocity and acceleration have the same sign. An object is slowing down if velocity and acceleration have opposite signs. So we're going to revisit this. We have done this before. So in example 5, I'm going to pause and give you a head start, see what you remember from earlier this year. A particle is moving along the x-axis with the position function x of t. Find the velocity and acceleration functions, then describe the motion, meaning is it speeding up or slowing down? So let me give you a few minutes head start on me. All right, I have found my velocity function. I have found my acceleration. And I've done my sine chart. Say that again? Correct. Yeah, that's why I changed it and put a big 0 there. All right, so I'm looking for same signs and opposite signs. So I would say the particle slows down from 0 to 2 and 4 to 6 because A of t and B of t have opposite signs. And the particle speeds up from 2 to 4 and 6 to infinity because acceleration and velocity have the same signs. All right, questions on that? That's just review. Pulling it back. In chapter 6 and 7, we will be doing antiderivatives. We're going to be doing the inverse of a derivative, and we're going to revisit particle motion. So that's why I just like to bring that back. All right, here's our last example, and I would put a gigantic star next to this one. This is a very, very common multiple choice style question on the AP exam in May. This is really one of them that you would likely see. It says, let H be a twice differentiable function. One of these graphs is H, the other one is H prime, and the other one is H double prime. So you're given Roman numeral 1, 2, and 3. Figure out which one was the original, which one is the first derivative, and which one is the second derivative. And then make your guess. I'm going to give you a few minutes to try to think about this. Here's something to maybe help you. Do you see in Roman numeral 2 it goes down, down? Here's where your pre-calculus comes in. You understand that a down, down end behavior has to be an even power? And then a down, up, this is some odd, and this is some odd. So that actually tells me that Roman numeral 2 has to be the middle. So that eliminates B and C right off the bat, okay? Now, I only need to do a little bit more comparison to help me. So here's where pre-calculus, ooh, if you had a really good pre-calculus experience, this really helps. So now, what you want to do is just sort of like compare, okay? Compare a couple of these. If I think that Roman numeral, well, let's see, if I want to go with A, if I think that 3 is a derivative of 2, then that would mean that my function would be decreasing from here to here, and that's not what's happening. So then let's go here and say, okay, well then, is this one a derivative of this one? And let's see. Do you see this is increasing till it hits 0. Then it decreases. Then it's increasing. Then it's decreasing. Oh, that's pretty cool. So it's letter choice D. And so if that didn't quite make sense, I went ahead and I found this online. It was fabulous. So it says, try picking 2 of the 3 graphs and see if one of them represents the derivative of the other. How can we tell that? Well, whenever the function is increasing, the derivative must be positive. Whenever the function is decreasing, the derivative must be negative. So if you looked at graphs 2 and 3, we can see that whenever 3 is decreasing, 2 is below the x-axis. Looking at 2 and 1 together, we can see that whenever 2 is increasing, the first one is above the x-axis. And so then that's why it's letter choice D. All right, that concludes the notes. So go ahead and pull up the 5-9 homework. And we've got, just under 15 minutes. Well, that's pretty good for us.